All right. Hopefully, let's see. Let's double check. And okay, cool. All right. So no one's online. And I hadn't planned any new material for this session, but and I haven't received any requests for any additional material I should cover. But something that we tend to skip over in Java a lot is something called enums. We've looked at the last session. We looked at primitive data types and even classes, and there's something that sort of sits in this sort of strange middle. And enums are really useful if you have sort of a set of things that are going to be possible entries. So like think of a direction that you can take north, south, east, and west. Those are four things. And you could store that as a numerical reference inside of a class, for example. You could have direction and then have it as some unsigned short or something like that. And then you're only using 0 through 4. The issue, though, is that the way that the data is being stored or the way that you're using it is hard to understand, because maybe you have to leave a comment saying 0 is north, and then anywhere that you go to say north, you have to look around and see it. Or maybe you make a variable called north and then you use that in very much the same way, where you're assigning north to direction, but really it's a variable. So enums are sort of a way to doing both of those things for us to have it. So let me type up an example and then I'll be right back. All right. So here we go. So let's make what I suggested. The there we go. So here we go. This is how we make an enum of that I suggested the directions. So we're going to call it direction, and it's a public enum, and these are the various values that an instance of this enum could hold. So then let's make one. Let's make a direction. We're going to call it direction. Actually, let's just call it dir. So this is the type. This is a type enum, and we're going to call it dir. And so I can store things in dir. So for example, I can store direction north in dir. And so then I can tell, I could say, I could see, is this north? And I could check if it's south. And so now suddenly I have this really elegant way of having code that's fairly readable to be able to tell which direction. Maybe you're making one of those console-based RPGs. And now, let's see, double check this. Test. There we go. Okay. Yeah, so maybe you're making an RPG and you need to keep track of what key that they pressed, and if they pressed a particular key, that you then decide the direction, or that you also use these directions for describing the things in the room or whatnot. So yeah, so there we go, we got direction. And what's cool is that these enums, let's just grab, let's just look at the example that's on the Oracle website for enums. So that was what they suggested up here. So all we did was we just did that programmatically, but you can do the same thing for an enum for a day. So the nifty thing is that behind the scenes, all it's doing is keeping track of these numerically. It's essentially making these constant variables well, they're not variables anymore, but they're constants, and then hiding and then putting the background, but assigning a name to them that makes them useful for us. So instead, now you could say day.Monday, and then you can use that. And what's cool is that you can plug that into other things, but you can also just make something of type day. So here we go. So here's an example of how you might use day in a class. So so this would be defined. This would be defined up above. So this gives us our enum, and then we're going to make a class called enum test. It's going to have an enum instance of day called lowercase day. It has its default constructor here. Well, actually, it just has. It doesn't have a default constructor. It just has this constructor. It has this constructor here that takes in a day and assigns the day. And then there's this method. Tell it like it is, and then based on the day, it's going to print out different things. So if it's Monday, Mondays are bad. If it's Friday, Fridays are bad. If it's Saturday or it's Sunday. So this, in case switches, as we saw, I think like the third week, that this is a way that you can handle multiple cases with the same result. So if it's Saturday or Sunday, weekends are the best. And then this default, so this is essentially anything that is not Monday, Friday, Saturday, or Sunday is going to fall under this default. So Tuesday and Wednesday, right, and Thursday, our midweeks are so-so. Cool. So here's an example of the main. So in the main, makes an enum test class instance and feeds in the argument Monday, and then tell it like it is. And so if we look at the code, it's Monday, so Mondays are bad, and so on and so forth. Cool. So enums are super duper useful, and you'll find them pop up in a lot of languages. Even C, which is a fairly primitive language, has enums. Yeah, they're definitely useful creatures. So something that gets overlooked a lot. That's what I got for enums for today. If anyone has any questions, feel free to email me, or send me a message on Slack or whatnot. Let me come up with something else that we can talk about. I think we'll look at some inheritance, which we haven't really covered in class yet too much. All right, so I think we're just going to deal with inheritance in regards to using the extends keyword. And so I'm just trying to come up with some class names. So we're going to make a class called size, and then maybe we have a class we're going to call item. Cool. So let's see. Just trying to think of what I need. Okay, so size, so it's gonna be, so yeah, let's start with this guy. And so for size, let's make some private parts. We're gonna make so for size, let's just have the dimensions, and let's see if I can. All right, so I'm quickly spell checking all of this just in case. Okay, so we're gonna have a few things. So we're going to have width, length, and height. And we might think of the type. In this case, let's just go with doubles. All right. Okay. So then let's make our constructor. So our default constructor will just set all of these things, this dot. I don't trust myself to type any of this out. And so this keyword is totally optional. The reason being is that there's only one instance of this of width here within this constructor. Okay. Okay, so there's our default constructor, and it just assigns all of these parts to be 0. And so now so I can keep them. So I'm gonna do both. So if we look at these, we can write it like this. And that's perfectly valid because now there's two things called width, and the way that we tell them within the scope of this, within this method, within this constructor. And so we look at, there we go. Okay, we look at the scope, and this keyword indicates this class. So this width is this width versus this width here is this width. Hopefully that makes sense. I know I'm using this for a few things, but when we're talking about this guy right here, we're talking about this guy. This guy is this guy. Cool. Okay. And then height. Sometimes you might just stick something like N for new or whatever. Keep in mind that the word new is reserved. So see how it highlights it. So maybe just N or whatever. So there we go. Now we have an overloaded size constructor and a default size constructor. And maybe we have some setters and getters. So we have a get width, and we're going to look at the type. It's going to be type double. I don't trust myself to type. That's why I'm doing all this copy pasting. And remember, getters don't take in any arguments in this case here. No, I was trying to help. Okay. So there's a getter. So this getter doesn't have to. It doesn't need any information in order for it to return width. Sometimes getters do. Sometimes getters have to have some kind of knowledge to get specifically what's being asked for. But in this case, it's nothing complex. So let's write our other ones. Say get, and then and so this is going to be get length. and then get height. Oops. All right, so there's all of our getters there. And then now we need some setters. So these are going to be of type void, and they're going to take in a double because all of our types are double. And then this dot then be whatever it is going to equal the n of whatever it is. Okay. And just copy pasta this 3 times. Okay. So we're going to say set width. So n width, this dot width, double n width, and it's going to be set width. Length and length. Oops. All right. So there we go. We've got all of our setters and getters for this size class. So it's just, okay. So now let's extend that size class into an item. Maybe we want to add some attributes to it. So let's make another class. We're going to call it item. And so we have our public class item. Okay, and then we're going to make so now let's use that keyword. And so right here, public class item, we're going to extend size. And so what this means is that everything that size has, we're going to have as well. So now item has a width, width, length, and height. But we can add things now. So maybe we, so let's for an item, let's have a string, and we're going to call it material. And maybe maybe a double for weight. So things like that. Lots of extra types. So okay, so let's make some constructors. So we're going to make the item public item. So this is going to be the default constructor. So the material we're going to set to none. For the weight, we'll set it to zero. And now we have to remember that we need to set all of these things too. And actually, let's be consistent. Let's say this dot weight, this dot material. So let's make sure that we're good. Let's let's see, has private access in size. Let me double check. Sorry about that. Yeah, so actually, because they're the private, they are only accessible from inside of the class in this private scope. So if we wanted to assign them, then we're going to need to use these setters here. So let's go and do that. So in this case, it would be, oops. Oops, that's not the right one. Okay. So instead, we would actually do set width 0. All right. Compiles must be good. Okay. All right. So let's overload this. So notice how we're able to call these as if we are ourselves. Right? Normally, when you are inside of a main or somewhere else, you would have an instance of this size class, and then you'd say that instance dot set width, set length, or set height. But in this case, we're able to call it as if we were inside of this, but that we have to respect the privacy settings of this. Okay, so let's make our overloaded constructor. So we have our string called material. We're just going to keep up the same exact the same naming scheme that we've been using beforehand. We have our weight, and we're going to call it weight as n. All right. Okay. So there we go. So we've got our n material, our n weight, our n width, our n length, and our n height. So notice how, so these guys here, just like in the default constructor, these are these parts, and then these are how we're setting these private parts over here. Cool, cool. Okay, and so let's make sure we haven't done goof somewhere. Yes, I did done goof. I have an extra comma right here. All right, compiles must be good. Okay, and so we can the same way that we made all these setters and getters over here, we would make setters and getters over here for these guys. How much time we got? Yeah, we got a few seconds. Okay. So we're going to make okay, so this is going to be a getter, get material. Get weight. Notice how I'm just copying and pasting as much as possible. If I was in an IDE, it would be, you know, like using Eclipse or JetBrains or something like that. I could I would be relying very heavily on the IDE to make sure that my spelling for things is correct. But because I'm using Nano here, really the only indication that I've done something wrong is the compiler. So I'm being much more extra cautious. Okay, so now we're going to have our void. This is going to be set material, takes in a string. This takes double. All right. All right. And so I'm just going to call these the same thing here. All right. And then I can just copy pasta this line here. All right. And because I'm extending it, all of these are exposed too. So if somebody makes an item class and they call set width or set length, it will work. And compiles must be good. So that's what I just came up for today. This extends. We don't need to know it right now in class, but when we were looking at the lists and array lists and things like that Jeff was talking about in class on Monday, this is how those classes do that. They use this keyword called extends to be able to essentially inherit all of the attributes that a parent class has. So hopefully now you can understand how they work and how they're able to do that, and the incredible power of it, because now every time you need to do something, you don't have to reinvent the wheel. You can just extend the wheel that somebody had already written, and somebody can then go and extend whatever you've written. And in Java, you see giant ladders of 20 things on in a specific order of them extending. One thing extends the next, which extends the next, and it branches out too. It's not just this vertical thing. When Tuesday in session, we were looking at how one class had lots of things that were extending it. So yeah, so that's what I got for you today. I'm going to jump over to Jeff's class. Good luck.